All right, this is a quiz review walkthrough for 8.5 through 8.8. So just like the last video, I recommended to you that since this is going to be a longer than usual video, that you should fast forward and rewind to the questions that you wanted to see done, as opposed to sitting there watching me do a 20-minute long video. All right, so we're going to get right into it. Every single problem on this worksheet, the directions are the same. They're asking you to factor each polynomial completely. So just as a reminder of what that means, factoring completely means you need to break down every term until you can't break it down anymore. So if you split something into two pieces and one of those two pieces can be split again, you need to keep going or you haven't factored completely. Okay? So if you remember, we have 4 different major factoring methods in addition to GCF, which works all the time, right? So the way that we're going to determine which factoring method to use is to look at the number of terms in the polynomial. So if you take a look at problem 1, problem 2, and problem 3, in each case they are binomial expressions, and there's only one way that we can factor a binomial expression besides GCF, which works for everything. Right? So in this case, we're going to look at problem number 1 and say this is a binomial. I can only use the binomial method for factoring, and the way that we said to do that was to take each term and write it as something squared, and then if we can do that with a difference in between, which we do have here, that we can rewrite it as, in this case, x plus 11 and x minus 11, which is each of the terms that we're squaring, the x and the 11, in both parentheses, one with a plus, one with a minus. And again, this happens because when I double distribute here, the 11x and the negative 11x cancel, and that's why I get a binomial. That's why this is the rule. Okay. Problem number 2 is the same thing, but when I look at 3x cubed minus 75x, they are not perfect squares. So I couldn't use the binomial method if I wanted to do these. However, I can first look at it and say they have a GCF of 3x, and when I remove that GCF, I'm left with x squared minus 25. And x squared minus 25 is a case like x squared minus 121. I can say that 25 is the same as 5 squared, and I can write, obviously, x squared is already looking like x squared, or looking like a squared. So I can say this turns into x plus 5 and x minus 5. And then the 3x just comes along. We're going to say this has got a big parentheses around it. 3x was sitting out there, which means in the answer it should be sitting out there as well. So don't forget those GCFs. If you write just this red part here, x plus 5, x minus 5, and you don't include the 3x, you haven't included all of the factors, so your answer is not complete. Okay? Same thing happens with problem number 3. I'm going to say 2 and 50 have a 2 in common, so I'm going to remove that. And I'm left with n squared minus 25q squared. And we can say that 25q is the same as 5q times 5q, which is the same as 5q squared. All right, so I'm going to say this turns into n plus 5q, okay, and n minus 5q. And the 2, again, is just going to come down. It's going to be sitting on the outside the whole way, and it's going to sit there at the beginning of this one too. So I'd say completely factored, can't factor any of the other expressions again. Okay. Once we move on to a problem like 4, what we were just doing no longer applies because now there are 3 terms instead of 2 terms. And when we get into 3 terms, trinomials, we have a little bit more work to do. There's actually 2 different cases for trinomials, and the key is to look right here. Right? If there is any number in this space, we can try GCF to try to get rid of that number, or we have to do the AC factoring method. For us, we don't have that problem. That's gone. So we can do what I call the easy factoring method, or the one-step factoring. We're going to set up 2 parentheses, okay? And we are going to find numbers that add to the end number. I'm sorry, multiply to the end number, and add to the middle number. So this is that table of values. You can say what numbers multiply to 12. Well, we have like 1 and 12, 2 and 6, 3 and 4. All right, this is a negative 12, so we have an additional little bit of work. We have to figure out, well, can I attach a negative onto any of these? So when I add them together, I get negative 4. And in this case, if you take a look at this middle one, if I put it right there and do 2 plus negative 6, I do get the negative 4. 2 times negative 6 will give me the negative 12. So when I fill this in, I'm going to say x plus 2 and x minus 6, and those will be my factors. Okay, so again, you have to look for the multiple numbers that add up to the middle, and that will be your answer. Okay? So there's a couple more that are trinomials that are like that. I'm actually going to do number 6 first because 6 is actually very similar to 4. Right? So I'm going to say in this case, what numbers multiply to 72, add to 17, and in this case, this is 9 times 8, and this is 9 plus 8. So I'm going to say x plus 9 and x plus 8. Right, so you can see in those cases, these are what I call the simple factoring method because it's one step and we're done. We don't have to do anything additional. Okay? When I take a look at problem like number 5 and number 7, right, they look a little bit more complicated. Okay, so again, I'm going to hold off on 5 for a second. I'm actually going to look at 7. You notice the difference between 7 and 6 is just this extra y that's in the middle and the extra y squared at the end. And the only thing that we had to do with those was we're going to actually say what numbers multiply to 10 and add up to 7. Right, this is still my multiply number and my add number. Right, so I'm going to say, well, 5 times 2, 5 plus 2. So if I was forgetting that y was there, like let's scribble it out for a second. Let's pretend like that's not there. Now this pretty much is the same as 6. I'd say in this case x plus 5 and x plus 2. And the only difference is, well, we have to figure out, instead of trying to turn something into 10, how do I turn it into 10y squared? Well, if I need that y squared to be there, the way to do that is to just put a y onto 5. And to put a y onto 2. Right? If you do 5y times 2y, you do get 10y squared. And if you check the middle, here's a 5xy and a 2xy, and that is 7xy. Right? So that's really the same type of problem. You just have to try to figure out how to get that 10y squared at the end, and that's by putting a y with 5 and a y with 2. Okay? So let's talk about problem number 5. Problem number 5 is, again, same basic idea. But this one, we have that 5 sitting at the beginning. Right? That's usually a problem. We would have to do AC factoring. Whenever there's a 5, right? That's the same thing that's going to happen down here in problem number 8. But for problem number 5, we get lucky because I can actually GCF because 5, 15, and 90 all have a 5 in common. So I'm going to take that 5 away and say t squared plus 3ts, okay, minus, and then I got to do 5 divided by 40. Well, that looks like 118. Okay, so I'm going to say 18s squared. Okay, and now this t squared does not have a 5 or any other number in front of it, which means I can treat it just like I did number 7. In this case, a lot like number 7 or number 6. Right? I'm going to say, well, what numbers multiply to negative 18 and add up to 3? Well, that looks like a plus 6 and a t minus 3. Okay? And we have to account for the s's as well, right? So we have the s squared at the end, just like we have the y squared at the end. So I'm going to put an s here and an s here. And 5 comes down, right? So I just bring the 5 down with it. So I'm going to say this is very similar to all these other ones, but I couldn't get to the point where I could do the factoring like I did for number 6 or number 7, that one-step factor, until I remove the GCF. So when I look in that first spot in front of t squared, there's nothing there to stop me from doing this method. Okay? So that's going to be different. If you take a look at problem number 8, I have that similar situation happening. I have a 3 in the beginning, and that's where we run into a problem. Right? I can't say in this case x and x, right? If I try to do this, well, x times x, well, that doesn't give me 3x squared, right? So that I can't do what I did up here. That's why we need to be blank in that spot, so I can put one of the x's in one of the x's in the other. That's the only way you can split up x squared. Once I get to numbers in front of x squared, this no longer works, so I have to get rid of it. So what we had for this situation, where what we say a is greater than 1, anything bigger than 1 in that x squared location, we're going to have to use what I called AC factoring. Okay? And what AC factoring is you're going to come off to the side and multiply together a and c. Well, 3 times negative 28 looks like negative 84. Okay? And then my b value in the middle here is negative 17. So your job is going to be to find a pair of numbers that adds to the b, which is nothing different. That was what happened over here as well, that middle term. Now it's going to multiply to this. Right? This is my multiply. So I have to go and figure this out. And if we get to these bigger numbers with AC, we have a calculator trick that I showed you that you can use. So we can say if I go to my y equals and I clear out whatever's in that space, so I have a clear button, I can type in what I want to find factors of, 84 works, right? Divided by x, because I want it to do all the dividing for me. Instead of me doing 84 divided by 2, 84 divided by 3, to find all those factors, I'm just going to say, well, you plug in the values calculator. I'm going to let you do it. So I'm going to hit my second button until I get that little up arrow. That means that I press the second button, and I'm going to hit the graph, and it's going to give me a list of factors. And I'm going to look for numbers on this list that add or subtract to the negative 17. So if I say does 1 and 84 add and subtract? Well, no, that's 85 or 83. Here I would get 44 if I add, 40 if I subtract. Here I get 25 if I subtract, I get 31 if I add. But if you take a look right here, 4 and 21. 4 minus 21, right, that's going to give me negative 17. So I'm going to say my pair of numbers is 4 and negative 21. That pair works. Okay? And the reason that we chose to figure out those values is because we're going to say now that I'm going to rewrite the expression 3x squared, but instead of writing negative 17x, I know that negative 17 is the same as 4 minus 21, right? That's what we just did here. So I'm going to say plus 4, it's a positive 4x, minus 21x, minus 28. Okay? And so I'm going to use the grouping method now, and I'm going to say, here's a group. Well, let's find the GCF of that. Pull out a common x. That's all that these two terms have in common. And it looks like I'm left with 3x plus 4. Okay? And I do the same thing here. It looks like these two have a negative sign in common, and they also have a 7 in common. So if I pull out a negative 7, well, that leaves me with 3x plus 4 as well, which is good because if you remember to the grouping method, the 4-term method, which you're going to see show up later, that extra term had to match. So I'm going to say 3x plus 4 is a factor. That's the common one. And the x and the minus 7 on the outside, the GCF terms, that's the other one, right? So this one you can see is much more complex to do. We had to do 3 steps, and we had to do a lot of work off to the side. We had to go to our calculator, and that's why I call this the simple method, because you can see in one step I'm able to fill in those blanks. For this one I had to do a lot of work to figure out what those terms were. So the easy method is whenever there's no number in this space here. More challenging if you can't get rid of it, right? Problem number 5, I had that number there, but I was able to GCF it away, and what I had left did not have it in that spot, and that's really what I'm looking for. Okay, so here's some more examples of AC factoring, or things that might be AC factoring. Right, I'm going to say 6x squared plus 22x plus 16. Well, if you notice, 6 times 16, that's a really big number. That's 96, right? So we'd have to find factors of 96. So instead, you always want to try and look for a GCF. 6, 22, and 16 do have a 2 in common. So I'm going to get rid of that. And it looks like I'm left with 3x squared plus 11x plus 8. Okay? And now, what I'm left with inside is still AC factoring, right? I did not get rid of the number in front of x squared, which means I still have to do AC factoring, but it's a little nicer because now my A and my C are only 24 instead of 96, and that's a little bit easier to work with. So I'm going to say my AC in this case, 3 times 8 is 24, my B value is 11, and it's going to be easier for me to think of factors of 24. In this case, 8 and 3 work. Okay? So I'm going to say 3x squared plus 8x plus 3x plus 8. Okay? All of this has that 2 sitting outside. I don't want to forget that, so I'm going to bring that down after I do all the work on the inside. So now I'm going to group, right? I'm going to take these first two. It looks like the first group has an x in common. It leaves me with 3x plus 8. And the second group doesn't really have anything in common, but we always know that every number has a 1 in it. So I need something on the outside, so I am going to show that 1. Right? And again, this all has, oh, let me close that one up first. Okay? This all has the 2 still sitting out in front of it. Okay? And now I'm going to regroup and I'm done. I'm going to say x plus 1 on the outside, 3x plus 8 on the inside. Right, from these two on the repeating one, and then the 2 comes down. Okay? One more AC factoring, because this again is probably the most challenging of all the methods. So again, I see 10, 15, 25. All of those numbers have a 5 in common. So instead of multiplying together 10 and 25 right at the beginning and getting a 250, then having to figure out factors of 250, I'd rather pull away that 5. So if I pull away this 5, it looks like I'm left with 2x squared plus 3x minus 5. Right? And now if I do my AC factoring, AC is only negative 10, and B is 3. And again, I know factors of negative 10. That looks like positive 5 and negative 2. Okay? So I can split up this middle expression, the 2x squared plus 3x minus 5, right? And I can get rid of that 3x and put these numbers in its place. So it looks like it's going to be 2x squared plus 5x minus 2x minus 5. Okay? So again, this all has the 5 out front of it. And now I'm going to use AC factoring. I'm going to use the grouping method now that I've done the AC part of factoring. And I'm going to say these first two terms have an x in common. And that leaves me with 2x plus 5. And the second group does have a negative sign in common, so I'm going to pull away -1 with a 2x plus 5. Okay? And again, all of this still has the 5 out front of it. So don't forget that 5, bring it down all the way to the end. Here's my regroup, x minus 1 on the outside. That's in parentheses. And the repeating 2x plus 5, that's in the other parentheses. 5 sits out front of it, and I would say this is my factored expression. Okay? Two more factoring. And these ones should be easy now, I hope, because we actually did all of this right here. Right? When I get to the second step of AC factoring, I have a 4-term expression, and I just have to do grouping. So this is really a 4-term expression, which means I'm going to do grouping. Right? So the only way that you can factor a 4-term expression is to group each of the terms, each of the pairs, and say what do they have in common. Well, I see x squared in common from these first two, so I'm going to get rid of that. And it looks like I'm left with 3x plus 1. So don't forget, when I GCF factor, I do need a placeholder, right? X squared came out of from the x squared, so I do need to multiply it by a 1. Okay. Second group, it looks like it has a 3 in common, -3 in common. So I'm going to say this again is 3x plus 1. Okay. So now I can bring down that x squared minus 3, and I can do the 3x plus 1, and it looks like I'm finished, right? This can't be factored again using the binomial method. Neither can that, right? Second one, I'm like, start grouping, but I'm going to notice right before I get started, hold on a second. 6, 15, 24, and 60, I'm not going to start the grouping method because they have a GCF, right? So again, I want to make my life easy, try to get rid of GCFs at the beginning. Well, it looks like 6, 15, 24, and 60 all have a 3 in common, and that's the biggest number. But again, that's going to make our life a little bit easier. So I'm going to say 2x cubed plus 15x squared plus 8x plus 20. And then I'm going to do the grouping method on just these little inside pieces, right? So I see an x squared is the only thing common because 2 and 15 don't share anything. So it's x squared times 2x plus 15. Okay? And, oh, let's fix an error. Okay? This is not 15. This is 3 away from the 15, which is a 5. Right? So let's fix that down bottom as well. Okay? So again, this is going to have a 5 in that spot. Okay? And again, now when I go to the next term, this group looks like I have a plus 4 and 2x plus 5. 2x plus 5. Okay. So again, I noticed that I made that mistake when I came down because I was looking at the second group and I was like, wait a second, when I pull that 4 out, I'm not going to end up with a 15, and that's what I had in this spot originally. Right, so I was able to catch my mistake as I went, and that's good for you to see that if you're not getting those matching terms, you know something was wrong. So I went to the line before and I realized where I made that mistake. When I did the GCF on all of the terms, I did miss one at 15. Okay, so that's a nice little mistake for you to see. So it looks like x squared plus 4, those are my GCFs, and 2x plus 5. Okay, and we forgot something, so let's not forget that coming down. This was all in a big parentheses with a 3, which means the 3 is going to come down. And I would say these 3 terms make the factors of this big original expression. And again, I want to point out x squared plus 4 is pretty close to difference of 2 perfect squares, but it is not a difference, so you should not have split this up again. Okay. One more problem, and that is the word problem. So this one's saying the area of an envelope is this expression 3x squared plus 11x plus 10, and they're telling us one of the parts. The length is x plus 2. They'd like to know about the width. So let me remind you about a simpler problem before we get into this one. Basically what they're telling us is something like this. They're saying, I know the area. Let's pretend like the area is 10. Okay? And I also know that the length of this shape is 5. And they're kind of saying, well, what's the other part of this expression? Well, you'd say, well, what do I need to multiply 5 by to get 10? Well, the answer is 2. Okay? So what we're really doing is we're factoring 10 and trying to figure out both of the parts that make 10, and that's how we're doing our answer. The only difference here is that they're giving us expressions instead of numbers, but the idea is still the same. So really what we're going to do is factor this expression. So I'm going to get rid of the rectangle. We don't need that anymore. Right? And we're going to say if I factor 3x squared plus 11x plus 10, I'm going to break it into 2 pieces. One of them should be x plus 2, and what I really want to know is what's the other one. Right? So we're just going to rewrite 3x squared plus 11x plus 10. Decide which method we need to use. Well, again, I'm looking at the trinomial expression, and I'm looking at a number here, which means I have to use AC factoring. So I'm going to come off to the side, AC. A times C is 30. B is 11. And I need to think of numbers that multiply to 30 and add up to 11. Well, that's going to be 5 and 6. Okay? So I'm going to break this up into two parts. And that's going to look like 3x squared plus 5x plus 6x plus 10. Right? So I just took 11, I split it up into 5 and 6. I'm going to pull away that common GCF. This first group only has an x in common. That leaves me with 3x plus 5. And the second group has a 2 in common. And that leaves me with also a 3x plus 5. Right? So now when I regroup, I get x plus 2 and 3x plus 5 are the two parts that when I multiply them together make this original expression. And so what they're really saying is, we know about x plus 2, that's this one. What's the other one? And so you're just going to say, well, the answer is 3x squared plus 5. Right? That would have to be the width, because that's the only thing that I could multiply with x plus 2 in order to get the original expression.